Good morning. My name is M. Narasimharao, lecturer in physics. Today, I am explaining about the cutting of the lenses. In majority times, in JEE exam, in the NEET exam, they are framing one question on cutting of the convex lenses or concave lenses. Now, I have taken one double convex lens. I have taken one equiconvex lens. I have taken one double convex lens or biconvex lens or equiconvex lens. I am cutting this lens along the vertical axis perpendicular to the principal axis of the convex lens. I am cutting like this, such that this convex lens is divided into two plano-convex lenses. Before cutting this double convex lens, equiconvex lens, biconvex lens, focal length of this double convex lens or equiconvex lens is f. Before cutting the lens, original focal length of the lens is small f. Its radius of curvature is r. This surface radius of curvature is r. First, I will find the focal length of this double convex lens. After that, after cutting the lens, we are getting two pieces of the plano-convex lenses. Next time, I am finding the focal length of the plano-convex lens. What happens to its focal length after cutting? I am talking about equiconvex lens. Now this is the one surface. It is another surface of convex lens. Now I am completing one sphere. Now this is the center of the sphere. Now this I am calling as a radius of curvature of the first surface. This is the radius of curvature of the first surface. This radius of curvature is plus r. For the same convex lens, for the second surface, I am completing one sphere. Now this is the center of curvature. This is the radius of curvature of second surface. This radius of curvature is equal to minus r. According to the sign convention regarding the lenses, this is the first surface of the convex lens, equiconvex lens. Its radius of curvature is positive. This is the second surface of the equiconvex lens. Its radius of curvature is minus r according to the sign convention. Both the lenses are same. Radius of curvature of this first surface of the double convex lens or equiconvex lens, R1 is equal to plus R. Radius of curvature of the second surface of the convex lens, that is R2. The R2 is equal to minus R. The reason is they told equiconvex lens, their radius of curvatures are equal. According to the maker's formula, 1 by f is equal to refractive index of lens divided by refractive index of surrounding medium minus 1 by r1 minus 1 by r2. r1 is the radius of curvature of first surface. r2 is the radius of curvature of the second surface. F represents the focal length of the equiconvex lens. 1 by f is equal to Refractive index of the lens they have given as mu. Refractive index of the lens material they have given as mu. Refractive index of lens material is mu by refractive index of surrounding medium. Surrounding medium is air. Air refractive index is 1. Surrounding medium refractive index is 1 into 1 by R1. Radius of curvature of first surface of the equiconvex lens. Radius of curvature is plus R. Radius of curvature R minus 1 by R2. Radius of curvature of second surface of the same lens. Radius of curvature is minus R. R2 means minus R. 1 by F is equal to mu minus 1 into 1 by R minus into minus plus minus into minus plus 1 by R, that is equal to mu minus 1 by R plus 1 by R 2 by R 1 by R plus 1 by R 2 by R. 1 by F is equal to mu minus 1 into 2 by R. Reverse this one. 1 by F. I am reversing the order. F by 1 is equal to. Here also reversing the order. 2 into mu minus 1 divided by R. If you reverse it, R by 2 into mu minus 1. Now this is the focal length of the double convex lens, or it is the focal length of the equiconvex lens. F is equal to R by 2 into mu minus 1, where mu represents the refractive index of material of the convex lens. R represents the radius of curvature of the lens. I am cutting the lens in vertical direction like this. Now, this equiconvex lens is divided into two equal pieces. Like first piece is a plano-convex lens, second piece is also plano-convex lens. The lens is cutted along vertical direction, which is perpendicular to the principal axis. We are cutting like this, like this, like this. Now, please listen. After cutting, what happens to the focal length of the plano-convex lens? What happens to the focal length of each piece of the lens? I have taken one plano-convex lens from here. This is the first surface of the plano-convex lens. Its radius of curvature is R. The radius of curvature does not changes. Radius of curvature of first surface is R. This is the plane surface. For the plane surface, radius of curvature is infinity. The reason is, if you extend this line down, if you extend this line up, both are meeting at infinity. For that reason, for the plane surface, radius of curvature is infinity. For the first surface, radius of curvature is R. Now I am applying the lens maker formula to find the focal length of this piece, which was taken from here. Now please listen. According to lens maker formula, 1 by F is equals to mu minus 1 into 1 by R1 minus 1 by R2. Now the lens is kept in air. Surrounding medium is air. Now please listen here. Focal length after cutting, focal length changes. Each piece focal length is F dash. Each piece focal length is F dash. 1 by F means focal length of each piece. Focal length of each piece is F dash. F means F dash. This is only the formula. that is equal to mu refractive index of the material of the lens. Here we have cutted the lens, but material was not changed. Material was not changed means the refractive index is same. Mu means I am writing mu refractive index of material of the lens, mu minus 1 by r1. Radius of curvature of first surface, that is plus r. Radius of curvature is r minus 1 by r2. Plane surface. Radius of curvature of plane surface. For the plane surface, radius of curvature is infinity. Radius of curvature is infinity. 1 by f dash is equal to mu minus 1 into 1 by r minus 1 by infinity. 1 by infinity is equal to 0. I am having 1 rupee. I have distributed to infinity members. Each one is getting 0. I am having 1 rupee. 1 rupee is divided with infinity members. I have 1 rupee. I am having 1 rupee given to infinity members. Finally, each one is getting 0. 1 by infinity means 0. 1 by infinity means 0. Mu minus 1. Mu minus 1. 1 by r into 1 by r. 1 by f dash, reverse the order. 1 by f dash, reverse the order. F dash by 1. That is equals to mu minus 1 into mu minus 1 by r. Reverse it. R by mu minus 1. Now, this is the focal length of the each piece after cutting the lens. This is the focal length of each piece. Focal length of each piece. Focal length of each piece of plano-convex lens after cutting. The focal length of each piece of the lens, plano-convex lens after cutting. This I am writing f dash is equal to numerator and denominator is multiplied with 2 r by mu minus 1. Numerator is multiplied with 2. Denominator is multiplied with 2. Numerator is multiplied with 2. Denominator is multiplied with 2. Now you please listen here. F dash is equal to 2 into r by 2 into mu minus 1. R by 2 into mu minus 1. R by 2 into mu minus 1. Nothing but F. F represents focal length of original equiconvex lens. Focal length of each part of the lens, f dash is equal to 2 times the original focal length of the equiconvex lens. Focal length of the each part of the lens is equal to 2 times the focal length of the original convex lens. After cutting the lens, focal length of the each piece is doubled. Focal length of each piece, f dash is equal to 2 times the original focal length of the equiconvex lens. Taken one double convex lens. Its focal length of the lens is f. It is made of material having the refractive index mu. R1 is the radius of curvature of the first surface. R2 is the radius of curvature of the second surface. Its focal length is small f before cutting the lens. After some time, I am cutting the lens horizontally along the principal principal axis of the convex lens along the AB direction, along the principal axis of the convex lens, I am cutting this lens. After cutting, it is divided into two pieces. After cutting, there is no change in the radius of curvature R1. There is no change in the radius of curvature R2. This radius of curvature not changed. This radius of curvature not changed. And the same lens I am cutting. Here material is having refractive index mu. Same lens. Here also refractive index of material of this half of the lens is mu. Please listen. Radius of curvature R1 not changing. Radius of curvature R2 not changing. Material of the lens not changing. Mu, refractive index not changing. Then focal length also not changing. Focal length of the lens after cutting also remains the same. According to lens maker's formula. According to lens maker's formula. According to lens maker's formula, focal length of the convex lens is equal to focal length of the lens. 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. This is the formula, right? Okay. After cutting the lens, R1 is not changing, R1 is constant. R2, radius of curvature of second surface not changing, R2 is constant. Same here, material is glass, here also glass, same material, refractive index is not changing. R1 is constant, R2 constant, mu constant. Finally, focal length of the each piece is constant. Focal length of each piece is f dash. Now after cutting horizontally along the principal axis of the lens, its focal length of each piece is f dash. R1 not changing, R2 not changing, refractive index not changing. Finally f is not changing. Focal length of the convex lens, focal length of the lens does not changes after cutting the lens along the principal axis. Focal length of each piece, focal length of each part or each piece of lens is each piece of the lens is f dash is equal to f. Now f dash, focal length of each piece of the lens is equal to original focal length of the convex lens. Focal length does not changes. Before cutting the lens, this object is placed in front of the convex lens. It's a focal length f. Now these are from the object. Light rays are emerging out, coming out. Those incident light rays are incident on the convex lens. Inside the lens, refraction takes place. After refraction, refracted light rays are converging at a point, forming the image. After cutting, only half of the lens is present. After cutting, only half of the lens is present. After cutting, only half of the lens is present. This is the object. From the object, these light rays are incident on the convex lens. After refraction, all the light rays are converging at a single point. This point we are calling as image. Now the light rays which are coming this side, they are moving away. They are not passing through this lens. only half of the light rays are incident on the convex lens. Those light rays are forming the image. Brightness of the image is reduced. Intensity of the image is reduced. After cutting the lens, intensity or brightness, intensity of image is reduced. Image is reduced. The reason reduced. The number of light rays forming the image on the other side of the lens is reduced. For that reason, intensity of the image is reduced. If the convex lens is having different layers made of different materials, two different materials means refractive indices are different. Upper part material refractive index is mu1. Lower part of the lens refractive index of this lower part of the lens is mu2. This convex lens is consisting of two different layers made of different materials. Different layers, different materials means refractive indices are different. Then focal length also different. Focal length of the upper part of the convex lens is f1. Focal length of the lower part of the lens is f2. The reason is, according to lens maker's formula, refractive index is different means focal length is different. If refractive index is changing means focal length of the lens also changes. This convex lens is containing two refractive indices, hence it will form the two images. The lens is made of two different layers, two materials of two different layers, then number of images is equal to 2 images. If this convex lens is made of 3 different layers of 3 materials, then number of images formed by this convex lens is 3. If this convex lens is made of different layers, n number of different layers, if the convex lens is containing n number of different materials, n number of different layers, n number of different materials, then number of images formed by this convex lens is n. If it is made of 3 different layers of 3 different material, number of images is 3. If the convex lens is made of 2 different layers of 2 different materials, number of images is equals to 2. The reason is, we are having one now. This is the object which is kept on the principal axis. From the object, light rays are coming out from the object. After refraction, this part of the lens is forming the image here. Now the light rays are coming from the object. After refraction, this part of the lens is forming the image here. This is the image 1. It is the image 2. The reason is, materials are different. Refractive indices is different. Focal length is different. Now, this part of the lens is forming the image here. This part of the lens is forming the image here. This convex lens is made of 2 different layers of different material. Hence, it is forming the 2 different images. The reason I will explain. According to the lens formula, focal length of the lens is equal to 1 by f is equal to 1 by v minus 1 by u. Minus 1 by u comes to this side, plus 1 by u. 1 by f plus 1 by u is equal to 1 by v. U represents the object distance. V represents the image distance. U into 1 u, f into 1 f by u into f, u f, that is equal to 1 by v. Reverse the order, 1 by v, reverse the order, v by 1, that is, reverse it, u f by u plus f. Now v means image distance, v means image distance. Here focal length of this material is different, focal length of this material is different. Focal length of this material is different, focal length of this material is different, focal length is different, hence image distance is also changes. Image distance for this material is this one, image distance for this material is this one. Now here, this material focal length is different, this material focal length is different, focal length is different means image distance also different. These two materials are forming two images. If the convex lens is made of two different materials as shown in this figure, it is nothing but this is one plano-convex lens, this is another plano-convex lens. This lens is the combination of two plano-convex lenses. This lens is the combination of two plano-convex lenses, or two plano-convex lenses are in contact with each other. This combination is having equivalent focal length. Formula, if the lenses are in contact, equivalent focal length 1 by f is equal to 1 by f1 plus 1 by f2. f1 is the focal length of this lens, f2 is the focal length of this lens, equivalent focal length of this combination is this one. Finally, one focal length. We are getting only one image. Thank you.